Hi, this is Kevin Trainer, and welcome to my tutorial for our coding assignment for uh, chapter 14 of the Severance Python book. Um, this part of the tutorial is part 0, and I've called it part 0 because it's really an introduction. It's not part of the coding assignment per se, in that it's not one of the exercises. Okay, it kind of sets the stage for the 4 exercises that are part of this assignment, um, and familiarizes you with the tools and the concepts. Okay, so ch- chapter 14 of the Severance Python book is about coding custom classes in Python, and that's what we're doing in this assignment. And the starter files, as they exist at this recording today in the spring of 2019, um, I have a picture of them right here on my monitor. So here's the zip file that I downloaded from our weekly schedule. Let me go back to downloads. It's called starter. At this point, it's called revise starter files for Severance Chapter 15 coding assignment. In here, I've expanded this, and you can see there are a couple things you need for this tutorial. Uh, there's the cheat sheet for creating custom Python classes for people who have taken our course. Okay, and then there's a bunch of files. Okay, uh, these dirty land mammals .txt and land mammals .txt are two test data files that we're going to use later on in the exercises that make up the coding assignment. Um, this is in a departure from what I've done for previous coding assignments. I've given you the code from the tutorial, and it's in a project called Practice Tutorial Severance 14. And this, as I practice the tutorial that I'm making now, here's all the code that I used. And the first class we're going to take a look at is one that we've already seen. It's called My Countries. Okay, and it should be familiar because we used it as a data holder class back in the coding exercises that we did for um, chapter 11 of the Zell Python book. And that was a couple of weeks ago now. Okay, so right now we're going to take a look at mycountries.py, and we're going to use it to kind of explain the cheat sheet. And these are two tools that you're going to be using in parts 1 through 4 of uh, the assignment. Okay, so let's look at the cheat sheet first. Okay, I've liked to create these over the years for the object-oriented courses that I've taught. Okay, uh, this is a cheat sheet for how to create a custom Python class. In particular, a class that we would use as a kind of a data holder class. Okay, classes have two sets of responsibilities. Uh, I often describe them as uh, to know and to do. They have data responsibilities and they have behavior responsibilities. And so the data is the to know, and the behavior is the to do. Okay, and classes uh, uh, kind of run the gamut in how they're how the balance of their data responsibilities kind of dominates the class, or their behavior responsibility tends to dominate the class. And these data holder classes, the data responsibilities really tend to dominate the class. By contrast, a lot of the classes that we've been using they come right from the Python distribution, from the different packages that we have to import from to use. Uh, a lot of them are more tool-like. Okay, they hold some data, but they have a lot of methods that we call to do work on the data. And they have a tendency to have more of an emphasis on the behavior side, right? So the custom classes that we're learning how to write in our course are really focused on the data side because they're data holder classes. These are things that programmers use to keep uh, records about the topics that they want to track, keep uh, record images in their program. So, in fact, the let's take a look at. I've already opened up this countries.py, which you've already seen. Okay, and let's make the code a little bit bigger here, just a little bit bigger. Okay, and here's countries.py. We used it back in our chapter 11 work, and this is a class that I designed, I wrote, and I gave to you to use. And it holds the data related to a country, its population, and its area in square miles. Okay. Um, and so here's the class. It's called my underscore countries.py. You've already used it before. Uh, and it follows a certain kind of pattern. Okay. First of all, um, what we have in our Python module is we have the usual kind of comments at the top that describe the module and its overall intention. And then we have two constants that we're using for our convenience in the part of the code in the module that does the unit testing. One's called passed and one's called failed. And this is a better documentation because it's sort of easier to read. These variables that we treat as constants in Python are just really technically regular variables, but we name them in all uppercase, which is the convention in a lot of languages for constants. And we have this intention that once we create them, that we're not going to be changing the values. So we put them up here inside the module, but outside any of the code, so that they can be seen by all of the code that's in the module on a practical basis. Um, and we don't really have to worry about sharing access to these constant-oriented variables because what we're really declaring is our commitment that we're not going to be changing the values once we created them. So that's where they are there. The two other things that are contained within the module are the country class, and that starts here on line 10. And let me just highlight it and go down. So here's the country class. Okay. And the next thing is, like a lot of modules in Python, we have a main. Okay. And in our course, we've used a convention that we put our unit testing code into the main. Okay. Do professional programmers actually put their unit testing code into the main? Probably not. Uh, they create their unit tests using well, the kind of tests that we create where we're not going to test by inspection. What we're going to do is we're going to predict the results that we're going to get from each one of the tests, and we're actually going to use the code in each of the test cases to check to see that the code from the class actually gives us the results that we're, we're expecting. And at the end of each of the tests, we're going to print either passed or we're going to print failed. Okay, so uh, the thing about kind of modern unit testing is that we don't test on the whole by inspection. Um, we have the program use our predictions about the output and actually test for it and look for it itself. And so we only have to look to see if the test case passed or failed. Okay? And it turns out that the main here has a group of test cases, and they are, how big are they? 4, 5, 6, 7, 7 test cases, and they're all there. Okay, and then the last thing that we have here is some code that's out in the clear, and it's the second line of it right here on line 158 uh, is a call to main. Okay, and it runs the unit tests, which we put into main. But there's this code on line 157 that only runs main if we've loaded this module all by itself. Okay, if we're working on the module itself and we're going to unit test it. Okay, so only test it if it's kind of in the circumstances that you see it right now. Uh, but for instance, the main code will not run if we import the module when we go to use this class as part of another program. So it won't run on imports, but it will run when we have the module open all by itself, which we do right now. Okay. All right. So those are the various parts. Now let's take a look um, at the cheat sheet, and I'm going to pop up a copy of the cheat sheet for you to see. And it's really a recipe for how to create a custom class once you know the requirements. So, what are the requirements for a class? Well, again, classes have responsibilities. They have data responsibilities, and they have behavior responsibilities. And we call those the data ones to know what does the class, what do instances of the class have to know, um, and to do what do instances of the class, what capabilities do they have. And the to know responsibilities are typically created with what we call instance variables. And the to-do responsibilities are implemented with methods, um, some of which are the special kind of methods that the names begin with underscore underscore and end with underscore underscore, so they're dundered, they're double underscored. So we don't access those methods directly, but they do represent the behavior. Um, but then we do have some methods that we do actually create, and their name is kind of in the clear. And typically, these are things, methods that calculate data values. So classes store their instance variables, um, and so when we want to access them in modern Python, we just go access them, and we'll see how that works in a minute. And there are some values, though, that we're not going to store as part of the data responsibilities. We're going to calculate as part of the behavior responsibilities, and these are typically of values that are implicit in the data that we stored. Okay, so if we had two kinds of weight that were the instance of variables for a class, and we wanted to calculate the total weight, we would provide the method calculate total weight, and so it wouldn't actually be stored, but we would get it from instances of the class by calling the method calculate total weight. And again, it's our practice to not store data explicitly that can be derived from the data that we do store explicitly. So this cheat sheet's got two parts. Okay, it's got a recipe for creating a custom class, particularly skewed to this data holder kind of class rather than some of the tool-oriented kind of classes that we see in the Python distribution classes. Although we do see some of these data holder classes as well there. And then because we're putting the unit tests right in with code from the class, we're putting the unit test in the main. I've got some hints about how to do the unit testing code. Okay? All right, so what other parts of a class? Well, the first thing we do is we create a normal Python module file. Okay, so let's look at the example file that we have. This one is called mycountries.py. Okay, and that's not because this is a great name for a module, but um, you'll know that the modules that we get as part of the Python distribution usually have kind of simpler names. And I usually call the ones that we use in exercises and we create ourselves. Uh, uh, I usually begin them with the word my, not because that's the only way to do it, but because it's our convention to know that these are modules that we created as part of our work. Okay. Would you do that in a typical um, professional programming team? No, you probably would have another naming convention that you used for your own modules that hold your own custom classes. But this is as good a convention as any, so I've decided to use it. So uh, this is called mycountries.py. It's got the same kind of comments at the top that we've been doing all through our course. Okay. what's the next one? Well, the next thing we want to do is we want to define any constants that are used either as part of the code that's in the class that we're creating or the unit tests. And for right now, we're only creating a single class per module, but there are people who put more than one related class into this the same module. One class per module is a good way to begin, though, because it's harder to lose your classes that way and not know where they are. Okay. So what we're going to do is we're going to define any constants. This is item 2 that are used in either the classes or the unit tests. And we already took a peek at those. In this sample class that we have, we just have a constant for passed and failed. And they're not used in the class proper, but they're convenience constants that we use in the unit tests. So if we go down to the unit test, again, I think there are 7 of these. And again, in this approach, in this kind of modern approach to unit testing, instead of unit testing by inspection, okay, we're going to have each of the unit test cases uh, know the predicted value and actually check for it with code and print either passed or failed. Okay, so that's how we get that. All right, and that's why we create the constants. So that's item 2. What's item 3? Well, we define the class. We put the class in the module. Okay, and it begins with a declaration class and then the name of the class. I put a class name here and then a colon. And let's take a look at that in the actual code. Here, the class itself is called country. Okay, and the naming conventions for classes are that they begin with a capital letter. Okay, and then they're in camel case. So a one-word name is just capitalized, and then the rest is in lowercase. But if we have a multiple word class name, we don't do underscores in between the words because we're using this camel case capitalization where we're capitalizing the first letter of every word. And this one is pretty simple. So this is the class header where we declare that we're declaring a class. And then of course the body of the class has all these code. Okay, and the code for the most part are all methods of the class. Okay, and they're all right here, and we'll talk about each of them in a minute. So let's go back to the recipe. Okay, what's the first thing that you do when you've defined the class? Well, the first thing you do is that you define a constructor. And what is a constructor? Well, it's a special kind of a method that has a special name, and it's another one of these dundered names. So it's a double underscore init, double underscore, and then in the parens are the arguments that you're passing to the constructor. All object-oriented methods, the first of the arguments is self, which is a reference to the instance that we're working on, and then we pass in the initial values of all the instance variables. And here I've just kind of called them generally init val1, init val2, etc. So for each of the instance variables that this class have, we pass in an initial value. So what do constructors do? Well, they actually take the instance of the class and they assign initial values such that the instance is completely populated. So they set the value of each instance variable in the constructor. But the other thing that we do by convention in these Python um, constructors is that we include code that controls the value type that's coming through and it's going to be stored in the instance of uh, variables. Python's very flexible about converting from one value type to the next, but what we want to do is we want to say, well, what type are we expecting to be passed, or do we want to convert to um, for this instance variable? And the kind of types that we're thinking of is it might be an int, a float, a string, a boolean, etc. Okay, so let's look at the constructor for this um, example class that we've already used before. And uh, here it is. It's right here. Okay, so you can see it has this name Dunderd uh, init, and then it has the formal parameter list. Always in these object-oriented uh, methods. And what's a method? It's just a function that's associated with a class instance. So it always begins with this reference to the self, which is the instance itself. And then we're going to pass in this case, we've got three instance variables: country name, population, and area in square miles. You might remember that from when we were using it back in chapter 11. And what we do is that we take these three initial values that are passed that we can access through the three formal parameters, and we assign them to the instance variables uh, country name, population, and area in square miles. And how do we know that they're instance variables? Well, all instance variable references begin with uh, the self dot notation. Okay, so self dot country name is the way that we define an instance variable called country name. The same for population, the same for area and square miles. And then how do we initialize each of those? Well, we initialize them with the formal parameters that we've been passed in. And um, in this case, a country name, population, and area in square miles. Okay. How do you call a constructor? Well, you call a constructor. I'm just going to type the code up here. Uh, but to create a new instance of the country class when we're in calling code, often called client code, we just use the name of the class. We say country, and then we pass in the values. So the country name could be USA, so we pass it a string for that. And the population could be 350 million. So we pass the value in for that. And the area in square miles might be, I forget what it is, but let's just say 25,000, which is, of course, way too small. Okay, so this is how you call a constructor. You use the name of the class. Okay, uh, so this dundered name of the constructor init isn't ever used explicitly. Okay, and that's true for a lot of these dundered standard names. Okay, um, it is never used explicitly, but it's used implicitly when you construct a country in the client code. Okay, and one thing to notice is that the as we retrieve the country name, the population area, and square miles, we put a call to the functions that convert whatever we're passed to the value type that we're expecting. So we're expecting the country name to be a string, so we call stir. We're expecting the population to be an int, so we call int. And we're expecting the area in square miles to be an int, so we call int. This does two things. One is it creates the documentation that you can just look in the constructor code to see what types it is expecting to get. But the other thing is if you pass it some other type, this code will convert it to the proper type. Okay, so this is a practice used by many programmers. It's a good practice where you can look at the constructor. You can see the instance variables right in the constructor. That's all the constructor does, is to define and populate those. And you can also see um, what types of the values have that you're going to pass into the constructor when you call the constructor implicitly in client code. Now this client code should not be in this module. I just typed it in here so you could see it. Okay, so that's the constructor. So where did that was in our cheat sheet in our recipe as item 4. Define the constructor. Okay. Okay, so that takes care of our instance of variables. In this example class, we've got 3. Okay, so what else do we have to put into the method? Well, we need to define some other methods to give our class the kind of services that we're expecting. And the next two are in items 4 and 5 of the cheat sheet. And when we want a string representation of the values in the class, the instance of the class, what we want to do is that we want to be able to, in our client code, call string or stir. Okay, on the we want to call that method on that class instance. Now, how do we code that in our code? Well, we put it into a method that has a special dundered name called stir. Okay, so the implementation of stir is in our class code as dunder stir. And the implementation of repr for representation is in dunder repr. Now, what's the difference between string and repr? Well, in most cases, most basic classes would only have an implementation of string. So that when you're testing, if you want to print the value of an instance of the class, that it's readable. Okay. Um, um, why do we have to do repr as well? Well, it turns out that some of the Python infrastructure, um, if you have a complex object, let's just say you have a list, and we're going to have this in the kind of classes and the testing that we're going to be doing. If you have a list that holds instances of a class, and you want to just print the list and see all the instances that are in there, well, it turns out that the list class, when it wants to print out all the instances that are have been used as items in the list, it calls the repr method. So if you really want a class that uh, that can be easily tested with print statements, you want to implement both repr and stir. So let's take a look at those in our example class. Uh, okay, we've got a bunch of code here because this is a not a basic version of a class, but a fully evolved version that we're going to learn how to create during this uh, later parts of this tutorial. It has a bunch of implicit getter and setter code, and we don't add this at this point yet, but this is where we definitely put it. We put it after the constructor and before the definitions for the string and the repr methods. Okay. So the next item on the recipe uh, is to define the string method and to define the repr method. So those are the next two things that we do. Okay. So the string passes a convention. A string passes back a string representation of this instance of the class, and by convention, what um, how we represent the object as a string is just the code that we would code into Klein code to construct it. Okay, and then this is kind of unique to Python, but it's a sweet little idea. So that the code for a country, um, the the string value has uh, a country and then a set of outer parens, and then uh, we have the values that you would pass to the constructor in order to construct an instance of it. So it shows the country name, the population, the area in square miles. Okay. So as we'll see when we build this, um, when we build our own class, when we test this, what we're going to do is we're going to see a string representation of that instance of the country class, but in a typical Python cute way, um, it's going to be the string is going to be the code that you would use in Klein code to construct that instance. Okay, and there's kind of a reason that they do it, but uh, better just explain that they do it, and it's cute and convenient to really get into uh, just the whole justification of it. So for our purposes, calling string or calling repr on the instance of a class is going to it's going to return the same thing. Okay, so we have no distinction between them, although some people implement classes do. So all we do in the repr class uh, is uh, is we return the string value. So in our recipe, uh, string and repr return the same code, and to keep from having redundant code, repr just calls string. Okay, and yeah, do you really have to have them both? No, you really don't have to have either of them, absolutely. But it's very convenient for unit testing to have implemented them both. Because if you get into trouble, you can always print the value, and you're going to see the value the easiest, even when things are in a list, if you have both repr and string. Okay. And again, these are dundred names in the class code itself, but we call str in the client code or repr in the client code, and under the covers it calls these dundred methods. Okay. All right. So what's left in our class code? Well, again, we've said that classes have two sets of responsibilities, uh, data and behavior, which are the responsibilities to know and to do. And everything we've done so far kind of centers around the data, the instance variable values. We've thrown in some to do with the string and the repr, but that's just to create the standard parts that will display the data values. Okay. Uh, do we have anything that's uh, do we have any other methods that we need to implement? Well, for every every value that this class instance has that can be calculated from the instance of variable values, we sometimes, for convenience and consistency, will define a method that returns a value that's implicit in the instance of variables, and it might be called something like calculate total weight. So we don't pretend that these are instance variables um, by giving them a name that looks exactly like an instance of variable name. We usually have a word at the beginning of the name like calculate or determine that says, oh, this is going to be a method, this is going to be behavior, although it actually returns data that a lot of people think of as being data values of the class, uh, properties of the class. Okay, calculate total weight, which in this was which that's not for our example class. It's just an example name. So, what kind of a method do we implement in our example class that has this character? Well, we've just got one. We've got this one here. Calculate a population density per square mile. Okay, and if we look at the calculation that we use, um, and when we calculate the return value, we're taking the two instance variables, population and area in square miles, and we are converting them to floats and doing a division. Okay, and that's how we're getting that done. And then we're rounding to turn the answer back into an integer because we want this to only return integer values. And that's what this version of round does. Implicitly, we're rounding it to 0 decimal places uh, here. Okay, so for every one of these calculated values, we're going to provide the implementation of a method for it. Okay, so that's pretty much what goes into a basic class. Okay, uh, you might say, well, we haven't seen any getter or setter code. And the fact is that basic Python classes don't have any getter or setter code associated with them like you might see in another language like, say, Java or C++. Because the way that we access instance of variable values in modern Python is we simply uh, the client code simply accesses the values of the instance variables directly. Now, this is compared to some of the principles of these more formal object-oriented programming languages like Java and C++. This is kind of heresy. But the modern Python people say that if you just want to access a data value in your class, you should be able just to use the value. Okay, and so that's what we're going to be doing in this class. Okay, so that's all we've implemented so far. What's left? Okay, well, you might want to add further methods. Okay, and here in item 8 in our recipe, in the cheat sheet, I say, consider adding further methods to provide convenience for the class user, the client code, or that implement advanced Python class features taught in more advanced Python courses. Okay, so the first part, the further methods that can provide convenience. Uh, that would be like more things like calculate total weight. Okay, maybe calculate total weight does it in pounds, and maybe we want to provide one calculate total weight in kilograms that does an implicit conversion for us. We can add things like that. There are also features that you learn in more advanced Python classes. More of these kind of dundered uh, methods. One is where you provide sort of a natural sort order for instances of classes. And there's all kinds of kind of superpowers you can give instances of your classes by learning about additional methods that you're able to provide. And they're really beyond the scope of our class. They're more for an intermediate Python course. Okay. So we're not going to do 8 in our course. Okay. If you think of another method you might add for convenience, well, you could certainly do that part of 8. But these kind of other dundered standard uh, method names that we might want to implement to give our class more powers, we're not going to be doing that in our course. Okay, now what's number 9? Okay, number 9 is something we're not going to be using in the first version of our class. Okay, so it says if and only if your class requires special getter setter code, for instance, of variables, Then add implicit getter-setter code for only those instance variables for which it is required using the property notation. Okay, so where's that in our uh, demonstration class? Well, that's code that I've already kind of pointed out. That's this implicit getter and setter code. Okay, and in this coding assignment, we don't do this until we get to exercise 3. So the first version of the class that we create in exercise 1 is a basic implementation. It doesn't try to control the values that you're putting into new instances. So uh, we create a new instance with a country name, population, and an area in square miles. And if you give them silly values like the empty string for the country name, or 0 for the population, or a negative a number for the population, or say a negative number for area in square miles, uh, the basic version of the class is just going to record it. A lot of times when we're creating a pretty simple data holder class, we don't give it a lot of extra services like error checking for invalid values. Okay, well that's what these implicit getter setter code properties do. Okay, we don't implement them until we get to part 3. We'll talk about them in part 3 of the tutorial, but we're not going to talk about them even in part 1, where we do the basic version of the class. Okay, it's we'll talk about them in part 3 when we do the evolved version of the class. Okay, and that's all the code that you can put in a typical data holder class. Those are all the possible parts. Notice that typically when we add this implicit getter setter code, we typically put it after the constructor but before the methods like uh, the implementation for string, the implementation for repr, and then worker methods, as I call them, like calculate population density per square mile. It's just where we typically put them. Okay? All right? It's not the order that we typically code them in, but it's where we typically put them. Okay. Well, what else does it say to do on our cheat sheet? Because this is how we're going to build our class. Well, we're up to item 10. And item 10 says, place all your unit testing code in the main method. This is a convention that we use in our course. Professional programmers place this same unit testing code in a separate class. Okay, that's a part of a unit testing framework. There are 2 unit testing frameworks for Python that are popular. Um, Unit test is one, and the other one is PyTest. They're really pretty similar in the way that they look, and the kind of code that you produce and put into specially named and specially located classes when you're using those um, professional unit testing frameworks, they have the style of the kind of unit tests that we've learned in our course. We're just not going to go through all the overhead of learning a unit testing framework. We'll leave that to an intermediate course in Python that you might take, or for your own learning on your own. Okay, but the kind of code that we put into main in our course that implements the unit test would be easily converted to a unit testing framework because we take the same approach that they take. Okay, so let's go find that code in our example class. Okay, and that's the code that's in the main. Okay, so here we've got one, two, three. I think we've got 7 unit test cases. Okay, so here's where they are, and then the last thing that we have is we have this conditional invocation of main, but there's a special entry for that on the cheat sheet. That's item number 11. It says invoke the main method with the final statements in your module, making sure that the test code only runs when the module is run by itself and not when the module is imported by another program. So we have this if test. Okay, so the if test we put in here is a standard bit of code. It's in the uh, it's typically available in Python textbooks. And what we're doing is that we're testing, are we have we loaded this module all by itself? In which case, we do want to run the unit tests when we say run, or have we imported this into another program like a report program in case, and so when we import it, uh, we wouldn't want to run the unit tests. So this keeps this from being run when we run the unit tests. Okay, so one of the things that you can see if you look at our code is if I go and run this code for my countries.py, the module that's sort of the sample module here, it runs the unit test cases. And here's the output from that. And I said there were 7 unit tests. Okay, and it's run all 7. And you can look, passed, 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 all the way through. So again, the kind of unit testing that we're doing, we're not testing by inspection, although we do have to inspect to look for past. Okay, but the real hard thinking and heavy lifting to know if each of the test cases pass is really in the test case itself. Okay, it has an expected result value for the test, and it prints passed if it got it and failed if it didn't. Okay, so that's okay, but we're only going to get that to run when we have the code loaded up like this. When we import the module into a different program and we import the class, in this case it would be the country class, the main should not run. And why shouldn't it run? Well, because we've got this test code here. We've got this test on line 157 before we have the invocation of main on line 158. Okay? Now, let's look at down at the bottom of our cheat sheet, and we'll see that we've got unit testing hints. Okay? So it says, uh, here's how we would prefer you to create the unit tests you put into main or wherever you're putting them. If you've already learned the more professional programming practices and you're putting them in the special place we put unit testing code in a formal unit testing framework, well, fine. But every time that we add a method to the class code, we really recommend that you immediately go and build and run the code for the related unit test cases. So what do we mean by this? Well, let's look. Okay, so we have our class code, which again highlight and show it here. We have our class code. Okay, let me come back up here and expand that highlight. We have that, and then we have our unit testing code, which is down in the main. I'll highlight that. And the naive way to go about the coding of this would be to write all the code for the class. We call that the production code typically. Right. This is down through the end of the test. And then write all of the unit tests. The problem with that is that when you find some errors in the class, it's going to be hard to debug them. And typically, people in my class, I recommend that you write a little production code, and then you write a little unit test code. And then you write a little more production code, and then you write a little unit test code. And when you find an error, you know that it's in the code that you just added. Okay? And so that's a good practice that we're going to recommend from our cheat sheet. So when you are in parts 1 and part 3 of this tutorial, in part 1 we build the basic version of the class, and in part 3 we add some code to create this evolved version of the class. Every time we add some code up here into the class, like we add the constructor, okay, well then we'll go immediately down to main and we'll add a test case for it. So typically your test case, your first test case is always test the constructor. So we want to know, for instance, if we pass valid when we pass inputs to the constructor, that we construct an instance of, in this case, in the example, it's the country class. And then we're going to go back and we're going to check, when we go to access the country name, do we actually get it back from the instance? And here, this is a good place to point out that unit testing code is client code. So here we can see how client code accesses the value of the instance variables in Python. So how do you access the country name instance variable in Python? Well, you just take the name of the instance. In this case, the variable is C1. And then you simply use the name of the field, country name. Unlike more formal languages like Java and C++, for more formal object-oriented languages, we don't call a getter method in order to get the value. We just access the value. So we do that for country name, we do that for population, we do that for area in square miles. In the unit tests, we compare them to what we expected the values to be, because that's what we initialized them with when we called the constructor. And if we get back the values that we wanted, well, then we're going to print passed. That's the way the code actually works. Okay, so add the constructor to the class, add a unit test case for the constructor. Okay, then add this, the string method. Then add the unit test case, then add the repr method, then add the unit test case. And each time you add the unit test case, you run the unit test to make sure that it actually works, right? And so you don't keep adding features into the class until you tested the one that you added before. So here, what did we do? Well, we tested the constructor, we test the string method, we test the repr method, we test the method that calculates a calculated return value. Okay, now what are the rest of the tests that we have here? I can see what tests 1 through 4 are. Well, tests 5, 6, and 7 are all part of code that we add in the evolved version of the class, which we actually don't do until we get to part 3 of the tutorial. And these things implement special implicit getter setter code that checks initial values for new classes, so you can't create instances that have silly values. Things like a country name that is equal to the empty string, or a population that is less than 0, or a area in square miles that is 0 or less. Okay, now that's where that code, that's where we're going to show that code in part 3 of the tutorial. And then we have the invocation here at the end. Okay, we've used up all the code that's in the module. Let's see if we've used up all the instructions on our cheat sheet. Well, we just have a couple of more hints about unit testing. The first one was every time we add a method to the class code, we immediately add a test case, some test case code to the main. The second says simple methods may need only one unit test case. Others may need more. Okay, the ones where we need more are going to be like the ones we do the error checking. We're not going to add those till part 3. Okay, so and when we create the basic version of our class, we're going to add one method into the class, and then we're probably going to add one unit test. It's only when we do fancier coding, like we do in part 3 of the tutorial, that we add one method and then we put 2 or 3 or 4 unit tests. And when we're doing that, we have to remember to create a separate test case for every error condition that we check in our code. And again, we don't do that till we do the evolved version of the class. So this one page is something that you can use for this coding assignment. You're also going to be able to use it. We do similar work in our final project. So you're going to want to keep this around for the final project. But you're also probably going to keep it around for your own coding. Because if in fact you're going to create a custom class and it has the character of one of these data holder classes, well, you can just use the cheat sheet. It's an easy recipe that you can follow, and if you follow it, you ought to be able to bang out these data holder classes pretty easily. Okay, you can create a real production line for them. All right, and again, just to look back at what we did, we had this demonstration class called country, and it we had the right name for the module. We had the right constants we used for convenience during testing. We had our class code, our production code from the class, and all that. added all that. And then we added into the main, we added all the unit test cases. Okay. And like we said in the hints, we probably should be creating the production code in the class and the unit test cases kind of side by side, not all of one and then all of the other. So create a little production code, create a little test code, create a little class code, create a little test code. And then when we're done with this, the way that we know with that we're done is that we run this class. We load up the module all by itself, and we run it, and it runs our test cases because that's what these kind of modules do when you load them up by themselves. They do not run their test cases. They do not run the main if you import them into another module, another program, which is what we're going to do in parts 2 and 4. So in parts 2 and 4, we don't want to see this output from the unit tests. And in parts 1 and 3, in part 1, we're going to create the basic version of the class. Well, uh, we're not going to want to see. We're going to be importing this module. These things are not going to run. We're not going to expect to see this in part 2. In part 3, we create the more evolved version of the class. Again, when we run that program from part 3, it's going to import the involved version of the class. We're not going to expect to see the chatter of the unit test cases running. And why? Well, we're not going to expect to see that because in our code for our class, when we invoke the main, we check first, do we have the module loaded all by itself? And if we do, then we run the test cases. If not, if we're importing the module, well, then we don't run the unit test cases. Okay? And just one final reminder, do professional programmers actually put their unit test code into main? Well, maybe some do, but typically what professional programmers do is they create the same style of test. This is the style of test that works in a unit testing framework, but your unit tests go in another module, um, uh, and exactly where they do go, and exactly what that module's called, and exactly how to run unit testing frameworks. That's something you either learn on your own later or that you'll learn in some subsequent intermediate Python course. So I'm going to wrap up here. This was just an orientation to a typical data holder class that we've already seen. We saw this back in chapter 11 of the Zell book. We saw that in the coding exercises we did for that. But what we introduced here is the cheat sheet. And so now we know the formula of how to create basically one of these classes ourselves. And it's been memorialized in the cheat sheet here. Okay. And where are we going to do that? We're going to do that twice during this assignment. In exercise 1, we're going to use this to create a basic version of our class. Okay? And then in exercise 3, we're going to use it to create a more evolved version of the class. How are they going to differ? The evolved version is going to include step 9. Okay? And the basic version is not going to include step 9. Okay? That's the only way that they're different. What do you usually do in your day job? Usually, it depends on how much of a hurry you are, but it's nice to have some error checking, which is what the evolved version creates. So, probably you're going to do the full job in your day job. You'll do number nine. It's not that much code once you learn how to create it. Okay, but those are additional features. You're only going to add if you need them. Okay. You may have data holder classes that never need these more evolved features. So maybe you'll never get to number nine. But of course, in our class, in our course, in order to do exercise three, in order to pass the final project, you're going to have to understand how to do that. Okay. So those are the new tools that you have. Um, I really expect you to just go through the cheat sheet and start at the top. And sometimes it helps to look back at another module that implements a class, a custom class that you know already works, and use that as a model for the code that you're going to produce. So that's the reason why I've given you this code uh, from a sample class country. Okay, you can use this to look back to what does the code actually look like for one of these custom classes when you go to write your own. Okay, to jog your memory. But for the most part, you're going to be following this cheat sheet. Okay, so I'm going to say bye for now, and I'll see you in part one where we'll go on to do exercise one of this tutorial. We'll do part one of the tutorial, in which part, when that's done, you'll be ready to do exercise one of the assignment. Bye for now.